Welcome to the database class. It's the lecture number 17. We are in the chapter of normalization. So today we will learn about the normalization, why it is used, and these sort of things. In the before classes, we have already know why normalization is used and its purposes. So why normalization? Normalization is basically involved when a lot of data are shown in the table are not working properly, or a lot of data which are useless. If a table is not properly normalized and have data redundancy, then it will not only eat up the extra memory space but will also make it difficult to handle and update the database without facing a data loss. Normalization is need to stop the data inconsistency, the three specific reasons that make the problem. So we are using the technology because we want a consistent system. If the system is going to the inconsistent state, if the data is not working properly, if the data is corrupted or going in an inconsistency state, then this data is totally useless. So basically for three reasons it is happening. It is insert anomaly, if the data is inserted anomaly, if delete anomaly, if the data is deleted without thinking anything, and if it is update anomaly. So we go for some more details. So why the normalization is need? Basically to understand these anomalies, let's take an example of a student. We show a table here. A student in a student table is having some attribute like student ID, student name, department, HOD, head of the department, and office telephone number. Here we have seen that in the student ID there are 4 students having ID 401, 402, 403 and 404. All of the students have different names, but they have the same department. They belongs from the same head of the department, and head of the department have the same office telephone number. So you may think it is quite normal, it is quite simple, but the thing is that in this above table we have see that the repeated data are coming, that is department is coming in repeated fashion, the head of the department is coming the repeatedly, same name we have to insert again and again, and the phone number it is same for all of the students. So it is came again and again for the 4 rows. If there are more than 100 students, so 100 times we are inserting the same data without any reason. So it is the data redundancy. So suppose for a new admission, unless a students get a department, so data of the student cannot be inserted. Suppose a student is qualified for admission, but if I want to give him a insert, or if I want to insert in this table, so we cannot do it because he or she still not get the department ID or department number. So we have to keep this field as null. After the students, when he is admitted, then we again insert the data for the same table. So that creates a lot of problem. So to now if we are going for a delete operation or suppose like that, so the same table here, in the same tables the data are same again, and the department, if we are we want to update, suppose like that, what if Mr. Todd leave the university, the head of the department leave the university or is no longer head of the department for the CSE department, there's another faculty, Mr. XYZ will be the next head of the department. In this case, student records will have to be updated. Okay, so for every tuple, for every row, this name will need to be changed. If by mistake we miss any record, it will lead to a data inconsistency. Suppose Mr. XYZ is suppose in your department there are more than 1,000 students currently in CSE department. So if the head of the department is changed after 1 year or 2 year, then what we'll have to do, we have to change all the datas for the name in the name of the head of the department. But it is not necessarily, because if we want to change it manually 1,000 data, it may have some problem. If something some data can be corrupted, some data will be facing the inconsistency state. So that is the problem of the normalization here. And if we want to delete some rows, suppose like the same thing in a student table, to different information are kept together, student information and department information. Here after a student, when a student is passed, he is no longer in the student list because he is already graduated, so he will be in the graduate list. So if we want to delete the data of the recently graduate students, so we need to delete them from the student table. Now if someone is mistakenly deleted a name who might have some carry or some clearance exam, so these students is no longer in the student table, he will be in the graduated table, but he is still having carry or clearance exam, so he will not permitted to give these exams because he is not in the student list. So without concerning all of the things, if you delete something anomaly, the data inconsistency will be happen. So that is the create a large problem. So that is why the normalization is needed. So there are several forms in normalization. In our database book, we have so far found the 7 type of normalization form. It is the first normal form, second normal form, third normal form. So in short, the first normal form is said 1NF, second normal form is called 2NF, and so long. So there is another normal form is called Boyce Code normal form, it is BCNF. And there is a fourth normal form, fifth normal form, and sixth normal form. There is a lot of normal forms, all of these. But yeah, by our syllabus, we'll go for the first 4, that is first normal form, second normal form, third normal form, and Boyce Code normal form. In the higher studies, whenever you want to a graduate level, then you will learn the 4th or 5th or 6th normal form. But I think you should be remembered, that is, if you know the first normal form, second normal form, and up to the Boyce Code normal form, your database will be consistent for a very long time. It is a fully consistent standard level. So you need to know the up to the Boyce Code normal form to get a good job, to make a sustainable database policy in your database. So if you make normalization in your database, so what the steps? So firstly, you have to specify the primary key. So if you forgot to mention the primary key in your table, you have to mention the primary key. If you have more than one primary key, you have to make a composite primary key for your table. So you need to declare the primary key totally specifically. Second thing is specify the functional dependency of the table. So you have to know which attributes will be the determinant and which attributes will be the object of determinants, because in the last class, in the last slide, we have so far know that determinants are controlling the attributes which are the object of determinants. So the third thing is apply the rules of the each normal form. So each normal form having a grammar, having some set of rules, having a constitutions to be a normal form. So whenever you are making normal, suppose like you want to make your database normal form like BCNF, boys code normal form, you have to start from the first normal form, then second normal form, then third normal form, then boys code normal form. So you have to follow from the lower part to the higher end. If the table fails to meet the rules and the condition of the normal form, change the table until it meets the rules and condition. So if your table is not in the normal form, it is not acting like a normal form, so you have to change your table. How your table can be changed? You have to add more attributes, or you have to delete the attributes, you have to break the tables into two tables or something like that. After that, you have to check again and again that the table is meeting the requirements or not, and if the requirements is fulfilled, then is okay. If it is not meet the requirements, you have to change again. Retest and the modified or new tables. So if you add or if you delete some attributes from your current table, so you have to retest, or you have to create some new tables to ensure they meet the rules and condition of each of the normal forms. So that is the end of the lecture 17. Thank you all again. Thank you.